So we've calculated a lot of zeros, right? And we've done what are the names of zeros that we've talked about? Let's start there. Let's summarize a little bit. We have a zero, right?
Yeah.
Okay, what's another name for that?
Root.
Okay, we could do a root.
X.
On the graph, it's called a.
X.
Are there any others? No. Okay. How did we calculate those?
Using math.
Okay. If I have a linear function and I want to calculate the zero, the x-intercept, how do I do that? Right, set y equal to 0. It would be something like this, right? Okay, so that's one method we can use with linear. And we use it with quadratics, right? Okay, so setting y equal to 0 and solving. When we got to quadratics, what methods do we use to solve this? We just went over them. Okay, quadratic formula. Complete the square. Love all these acronyms. Huh? Factoring. Okay, we'll lump that all in one. And graphing. Okay. Factoring, obviously, we can do lots of stuff like slip and slide. We can do the Punnett square. We can do guess and check. Right? We can also do greatest common factor. Remember, that's first, right? So you're starting to get a lot of stuff in your mind, right? You keep that organized, it helps a ton. And if you're writing all this down right now, this is a great place to put, or the blue sheet when you get one is a great place for that stuff. Okay. Today, we're going to start moving past quadratics into cubics and using synthetic division to help us find some zeros. Okay.
Does the quadratic formula not work for us?
No, because it's a quadratic formula, not a cubic formula, right?
Is there a cubic formula?
No. There are ways to solve cubics. That's not one of them. Okay. In your book, okay, your book calls this section the rational, or see, I don't even worry about it. The remainder and factor theorems. Yeah, remainder and factor theorems. So I'm kind of not mentioning those, but that's basically what we're doing. Okay. All right, so if I were to find all factors of this here cubic, if x plus 1 is a factor, this is a perfect set situation for the synthetic division. Okay. So basically what synthetic division is going to do, it's going to take this, we're going to divide, and it's going to give us a quadratic out the backside. We might be able to factor the quadratic, right? So this is going to reduce our work. If I have a factor, do you remember, you went through this last year, right? Okay, so you remember the setup?
Oh yeah.
This is what we're looking at.
Yeah.
So, yeah, this is good. I don't even like. There's a long division method for this.
Don't do it. It's not difficult.
I don't even teach it to you because this is so much easier, right? So, what do I take out of that?
Plus 1 and put it in the...
It's got to be -1. Okay, remember it's the opposite there. Okay, we're living in opposite land. It's connected with the x, right? Remember that from families of functions? Same theme here. Okay? What goes here?
1.
1, -1.
Plus 2.
Put this here.
0 because there's no x.
There's no x here. We have to remember to put every single variable of x in here. Okay? So be careful there, because it'll screw you up totally. Get the wrong answer. Okay. All right. If you guys sound like you remember it, so what do I do?
Drop the first number down.
Okay. And
1 times 1.
multiply those two, correct? And? Yeah, you add now.
-1.
Okay.
Wait, what?
Add.
Drop your first number.
So, do you do -1?
Then you subtract.
Now, it's always multiplied by this number.
-1 times -2
So we get
Oh,
2.
no, it's +2.
And then what's that? 2. Now we multiply again. -2, and we get, woohoo!
Wait, why is it -2? Oh, because you put -2.
2 times -1 is -2. All
So
right.
you change out a value.
Okay, so here's the nice thing. There's no remainder, right?
Yeah.
So that means that is a factor, right?
Nice.
What is my resulting polynomial?
1x squared -2x plus...
Does anybody not know how we got that? Okay. X cubed divided by x is x squared, right? That's our first term. Okay, you are dividing x cubed by x, right? That's x squared. That's our first term.
If there was a remainder.
If there's, if there was a remainder, this wouldn't say that that's a factor. Okay, so we kind of set you up here. This is a factor, so there will be no remainder. Done deal.
When there's a remainder.
I'll show you one with a remainder.
You just put it over x1, right? Or whatever. that
Yeah,
is.
so if there was a remainder here, it would be plus 0 over x plus 1. Right? But we don't have to worry about it now. So, okay. So my resulting, come on, polynomial so far is right there, correct? This polynomial is the same as that. Can I factor that quadratic now?
Yes. Yes.
Oh, I get this now. Darn
No.
genius.
Yell it louder, it might make it true.
No.
That wasn't louder.
Oh.
Can I factor that?
No. Yes.
Yes.
Yes or no?
Yes.
It's a simple a equals 1 quadratic. So what are my factors of 2?
1 and 2.
1 and 2, or -1 and -2. Do either of those pairs add up to -2? -2 plus -1 is -3.
Oh.
2 plus 1 is 3. Nope. Okay. Thank you for letting me be a 5th grade math teacher. I like it a
Wow,
lot.
I was telling you no the whole time.
Are we good? So if you can factor that quadratic, you would continue, but there you go. All right. Are we good with that one?
Yes, sir.
So wait, that's what you just.
Kellen, you are on it today. What?
What, the way you just circled was.
That's the answer. We found all the factors.
Those are all the factors.
Yeah, because we cannot factor this quadratic, right? Very tasty. Okay. Let's try another. Okay. Find all zeros of x cubed minus 2x squared minus 13x minus 10 if 1, 0 is 5. Okay. We have the same question as last time, just worded differently, and you have to take it a step further. So, if 1, 0 is 5, what do I put here? 5. So if it's a 0, it goes right there. Versus a factor. What's the 0 of that root?
Oh,
Negative 1.
that's genius!
Right? You see the connection?
No, connects.
You bet.
It's like a puzzle.
So, but if it's a 0, you're looking at putting that right there. And then we have 1, negative 2, negative 13, and negative 10, right? Okay. Since you're geniuses, Wile E. Coyote super geniuses, why don't you try that on your own? Do that. Anybody need help?
Would you do -2 minus 5 or +5? -2 minus 5.
What was that?
15 plus negative 13 is 2. Or 13 plus negative.
It's 2.
So it has.
By 5.
No, negative 8.
Paul, you got a negative here? It should be positive.
Oh, you're right.
Oh, you're right.
All right, so you should have that. This is not dumb.
No.
Don't be dumb.
5, and that's -2.
So, what quadratic is this? X squared plus 3x plus 2,
Okay.
right? 1x squared. Can I factor that?
Yes. Yes.
Educate me, Kellen.
Come on, Kellen.
You just simply do 1 and 2.
Right?
Yeah.
So what are the zeros? X equals -2, -1, and 5. A little different situation there, but not really. Boom, shalaka-laka. Right?
That is
What?
I've never done this before, so I'm trying to kind of explain that story because without air. Yeah, I had 625.
That'll do it. Pretty sure. Hey, you want to do some calculus for your responses?
No.
I don't want to scare you.
You say calculus for your responses?
Yeah. Okay, so I'm just gonna work. Okay, so Google Classroom, the post for this section is 3 days long, right, on Google Classroom. Each day has its own work. Okay, this is what you should be working on today. Okay, so I'm going to give you, I'm not going to actually ask you to do them all, but this is what it looks like. Okay, so it's the same thing we just did, right? Factor and find the zeros, one factor's been given, right? Or when you come down to the second page, factor and find all zeros, one zero's been given. Those two samples I gave you, right?
Yep.
So, let me write down.
Demonstrate how to do 14.
So on the worksheet, 179, 13, and 17. Then 4.3 spiral. This is just the review questions.
What does that say?
Worksheet.
Oh, yeah.
So this is the worksheet that's posted,
Okay.
and it's deep. You know, it's in there too.
You want us to do all of these on the same sheet?
That's fine.
It wasn't deep enough for me.
Okay. So that will apply for today. Let me give you one more. You got that written down?
Yes, sir.
1, 2, 3.
Buckle
Hurry
my
up.
shoe.
Okay. The other thing that you might want to. I'm almost done. Be quiet, please. The other thing that I have there is a factoring summary. I gotta find it here. What's it called?
Just look it up. Search.
Search. Yeah, I don't want to type on this board. Polynomial factoring summary. Okay, this is posted there as well. Okay, so it's kind of a different way to look at factoring. Okay, so again, number one thing you do, is there a greatest common factor?
No.
Okay, yes or no, and if there is, you factor it out. Okay, on this sheet, it breaks it into greatest common factor, but then is the, we haven't gone over difference of squares, but is the equation a binomial? These are the methods you can use. So if there's only two terms, okay, two terms, those are the methods you can use, and we'll go over those next week. We've been working with trinomials, right? A, B, and C. So you can factor, okay, if A is 1, A is not 1, okay, lots of ways. And then the other part of this is if it has 4 terms, and then go over that next week. Okay, so that's there if you want to use it as a reference too. It does not have the slip and slide in it. this AC grouping method is basically the Punnett square slip and slide method. It's just not visually appealing like those are. Okay, no. I can edit that if need be. But, so that's there too, if you want to use it, okay? Yeah.